This is the gold foil experiment. So this is the setup. Masses of unknown diameter are placed behind a board so the person that's launching the pennies cannot see them. The person that's launching them is using a mass and hits the pennies down and counting the number of times the pennies hit the masses. This experiment recreates Ernest Rutherford's gold foil experiment. In that experiment, Ernest Rutherford aimed alpha ray particles at a thin gold foil. He expected all the alpha rays to go through the gold foil. However, most of them went through, but a few of them ricocheted. For this experiment, you'll need masses of unknown diameter. That's what's going to be measured in this experiment. These masses will represent the gold nuclei. You'll also need some pennies. These pennies will represent the alpha ray particles. You'll also need something to hit the pennies at the unknown masses. This is to randomize where the shot goes. Let's go over the equation that will be used to measure the diameter of the unknown masses. Capital D is the calculated diameter of the unknown masses. Capital H is the number of times the pennies hit the masses. Capital W is the width of the track. In this experiment, it's 50 centimeters. Capital S is the number of times the pennies are shot at the unknown masses. In this experiment, we collect the data at 20 shots, 50 shots, and 100 shots to see if the number of shots affect the accuracy in measuring the diameter of the unknown masses. Capital N is the number of unknown masses. Here, it's 3 unknown masses. Lowercase d is the diameter of the penny. It's 1.9 centimeters. Now let's go over what counts as a shot and what counts as a hit. The only thing that counts as a shot is if the penny hits the masses or hits the backboard. Let's go over what does not count as a shot. If the penny does not make it down to the masses or the backboard, that does not count as a shot. If the penny ricochets off the side and goes down the track, that does not count as a shot. Now let's go over what does and doesn't count as a hit. A hit is when the penny hits the masses. It does not count as a hit if the penny ricochets off the backboard or anything else and hits the masses. It does not count as a hit if a penny hits another penny into a mass. If a penny hits one of the masses and ricochets into another mass, that only counts as one hit. So now let's do the gold foil experiment. We're going to hit 100 pennies down this path, and we're going to record the number of hits at 20 shots, 50 shots, and 100 shots. So now that we've done that experiment, we can use that equation to calculate the diameter of these masses. You can see here the data that we collected on the 100 shots. Now we can use that data to calculate the diameter of the unknown masses. The calculated diameter should be different for the number of hits at 20 shots, 50 shots, and 100 shots. Now we can use the meter stick to measure the actual diameter of these unknown masses. You can see here the masses are 5 centimeters. So now we can use this equation to calculate how the number of shots affected how accurate the calculated measurement was. So some questions we should ask ourselves is, well, how did the number of shots affect how accurate our calculated measurement was? Why was the person who was shooting the pennies down the path not supposed to be able to see the masses? How does this experiment represent how Ernest Rutherford measured the diameter of gold nuclei? Would you expect more or less hits if a different sized coin was used? What happens if we used a dime? What happens if we used a quarter? Would that affect the number of times that coin hits the masses? Another question we can ask is, how is this similar to echolocation? Once again, this is the gold foil experiment.